Good morning all. Applications of integration is coming up. I apologise for my morning voice and morning brain. It is currently 7 o'clock. So, sketch this. Alrighty, that's easy enough. So application of integration is just like all the other ones, basically areas and potentially some velocity or something like that. Well, that's nice and straight for you, Sophie. Enjoy. Oh, there's another one that's not straight. Go away. Oh no, that's just the same one that I'm moving. There we go. Morning brain in full effect. Cos half x. So the half there, that stretches it out. And so the period is 2 pi divided by a half, which is 4 pi. So this is why they've got a 4 pi there. So cos starts at 1, so that'll just be 1 thing, period. And then the easiest way to mark the intercepts is to divide everything in half. So there's your 4 pi divided in half. There's 2 pi down to minus 1. So that makes this one here pi and this one here 3 pi. Hence find the area between that, and that. Okay. So now you've got to be careful here because the area is the 2 yellows, which are positive, and the blue, which is negative. And I hope it's fairly obvious that all of these things, because of symmetry, the thing that I'm labeling 1 there, the thing that I'm labeling 2, 3, and 4, they all have the same area. So the absolute value of area 1 is equal to the absolute value of area 2, and so on. And so what I could say for part B is that area is 4 lots of the area from 0 to pi of cos 1/2 x dx. That's the easiest way to do it, I suppose, because then you don't have to do multiple integrals. Otherwise, you'd have to do 0 to pi and then do pi to 3 pi and make it absolute valued, and then do 3 pi to 4. So I can do that, and then I do my little standard trick where I want a half there to match this one. So that means I have to multiply by 2 to fix it up. And so I get that this equals 8. Oh, that's a different purple. That's better. Equals 8 sine a half x between 0 and pi. And sine, the derivative of sine is positive cos because it starts at 0 and goes up. And then that's 8 sine pi over 2, which is 1, minus sine 0, which is 0, so it's 8 units squared. Done and done. Next one. Show that these curves intersect there. So I'll just write sine x equals sine 2x. So it says show, it doesn't say solve. So if it said solve, I'm actually going to do this the long way because I definitely need this skill, and it's actually one of the next topics we do. So you don't divide by sine x because you're going to make that 0 in the end. And if you divide by it, the solutions go away. So you do the double angle formula like I've done. Take the sine x out the front, and you get 2 cos x minus 1. So either sine x is 0 or 2 cos x is 1. Cos x equals a half. I'm just feeling a picking on Sophie mood kind of day, and Sophie's going to tell me the exact angle there. So this one's x is 0. And this one is, surprisingly, pi over 3, 60 degrees. All right. So there's that bit done. Because it said show, what I could have done is just written this and then written left-hand side equals sine pi on 3 equals whatever. Right-hand side equals sine 2 pi on 3 equals whatever. And they're the same. Part B. Excuse me. Sorry about that. sketch these curves in the interval from 0 to pi. So this is actually true at pi as well here. Sine x equals 0 at pi. So let's just squeeze it in here. So sine x does that to pi. Sine 2x does a full period, so it will pass through here and here. So like that. Okay, and here's pi over 3. Find the area contained between the curves in this interval. So that's this bit here. Sorry, I forgot to label. So the area is top minus bottom. The top is sine 2x. Bottom is sine x, and the limits are 0 over 3. So that's a half cos 2x negative plus cos x. I don't know if you can hear Max on that side, but he's going dirty pig, dirty pig. It's very cute. Okay. Negative a half cos 2 pi over 3 plus cos pi over 3 minus, and then it's cos 0, so it's minus a half cos 0 plus cos 0. So cos 2 pi over 3, look at that, I've got the triangle up there. So it's negative a half times cos 2 pi over 3 is negative a half plus a half minus a half times 1 plus 1. So that's a quarter plus a half plus another half plus 1. So I believe that's 2 1/4. And you'll no doubt tell me you did that wrong, Dr. Emanuel, later. Okay, last one, and then I've got an enrichment one down here that we might do together in class, I think. Show that the interval blah blah blah. Okay, so to show that they intersect, the easiest way to do that is to divide by cos. And just note here that cos x cannot equal 0, which is fine, because if cos x equals 0, then the original equation, which I'll highlight in green, doesn't solve anyway, because if cos x equals 0, then sin x would also have to be 0, but we know that never happens at the same time, okay? Because if one of them is 0, the other one is always either 1 or minus 1 by the unit circle. And if one of them is 0, the other one is 1 or minus 1. So then we get tan x is 1, which is x is pi over 4, or 5 pi over 4 in this domain. Sketch them and find the area bounded by them. Easy peasy. So 0 to 2 pi, right? So here's sine. I don't know why I never draw my x-axis long enough. I always miss it. And cos. So here is the relevant area, and they meet at pi over 4 and at 5 pi over 4. And so the area, pi over 4 to 5 pi over 4, top, which is the grey one, so that's sine, bottom, cos x. Okay, sine goes to negative cos, cos just goes to positive sine. Get ready, Sophie. Or am I going to mix it up and pick on someone else? Alright, Sophie, you can tell me who to pick on. You want me to pick on Jess? Alright, Jess, you tell me. What is cos 5 pi over 4? If you get this wrong, you're not allowed to eat chocolate for 24 hours. I was actually eating a muesli bar yesterday while I was teaching you guys. I was like, oh, this is fine because Jess isn't here. And I won't give her an anaphylactic reaction. This is good. So here's 5 pi over 4. Third quadrant, related angle is pi over 4. And cos pi over 4 is very good, Jess. 1 on root 2. As is sine pi over 4. This is all stations to central, so over here they're both negative, so this is cos becomes positive 1 on root 2 plus 1 on root 2 minus negative 1 on root 2 minus 1 on root 2, and those negatives all cancel out, and we end up with 4 over root 2. Alright, because this becomes, these all become pluses, and when it's like that, you really should, I mean, there's never a mark for it, but a good mathematician will do it. Okay, we'll do the enrichment in class, and I'll see you soon. There's a code up the top for a Zoom meeting, I hope. Bye.